Fiber reinforced PET is great technical filament with affordable price, but is there any difference between the colors and which one is the strongest? Let's find out. Welcome to my tech fun to another filament testing video. This is Polymaker PET-GF15, and I already mentioned several times that the PET slowly became my favorite filament type. Great technical filament with a quite affordable price. In this case it is cheaper compared to the carbon fiber version because it is around $30 per kilogram. Of course this may vary from country to country. GF is the shortcut for the glass fibers and 15 is the percentage of the fiber material in this filament. It is available currently in 6 colors, and with the glass fibers we have more freedom compared to the carbon fibers, which are black, so we can have more lighter colors too. High strength and great layer adhesion, and this is very important property. They claim much better layer adhesion compared to the carbon fiber version, which also had quite good layer adhesion. Heat resistant engineering filament. Heat diffraction temperature up to 133 degrees Celsius after annealing. About this annealing, they claim on their website that it helps mostly with the temperature resistance, and if you need HDT above 80 degrees Celsius, then annealing should be on 120 degrees Celsius for 16 hours, which is quite a long time, but of course they must give specifications which are good for any object. My test objects are quite thin, and actually I will do the annealing only with the test objects for the temperature test, because mechanical properties, according to my experience, don't really change significantly after the annealing, only temperature resistance. AMS compatible, which is interesting information. You know, AMS compatibility needs two properties, low friction and not brittle filament. And probably here we will still have quite big friction, so AMS2 is better, more compatible than the AMS, but I will check this later. And high speed filament up to 250 mm per second speed can be used, but even on their website they suggest if you need a better layer adhesion, you should reduce the speed a little bit. Dimensional stability and low warping, and this is definitely correct. Fibers always helps here, and we will have much better dimensional accuracy. Hardened steel nozzle is recommended, of course. And print settings, the temperature between 280 and 310 degrees Celsius, and the bed between 70 and 80 degrees. It is important to mention that not only this video, but the whole channel is sponsored by Polymaker, but don't worry, these don't have any effect on my experience or measure results. But yes, that's the reason why I have so many colors in this test, otherwise I would have only one or two. But in this case I couldn't reject testing all 6 colors. And these colors are white, light gray, dark gray, black, red and blue. And I will try to keep this order during the testing too. Nice vacuum packaging, and this material protects the filament better from the moisture. The bag is resealable. On the sticker, same print settings already mentioned, and nice to see information about weight of empty spool, 166 grams. Sometimes companies forget about how important is this information, and approximately on this scale we can see how much filament we have on the spool. It has nice matte surface. For the touch it has more friction compared to the non-fiber reinforced filaments, but definitely less compared to the carbon fiber. Let's see how brittle is the filament. Not really brittle, let's measure it. Start angle 30 degrees. Around 110, so this is not a brittle filament. One important information I'm missing here, what is the maximal drying temperature? For the filament or for the spool? For the spool earlier it was around 100 degrees Celsius, the limitation is the glow inside. Because I know that PET, CF or GF, they're fine, I will use them out of the box, but if I store it and I want to reuse it after half years maybe, in that case I have to dry it before the use. So these are those 6 colors without packaging. I'm starting with white and printing will be on H2S. I double checked, Polymaker claims that it can go into the AMS and all printings will be using AMS2 Pro, which is more prepared for these abrasive filaments compared to the first generation. Since it has ceramic inlets and it is easier to disassemble it if necessary. Currently the profile for H2S is not available, so I analyzed the profile for X1 Carbon, which I downloaded from the Polymaker's website. Let's see those numbers. On the bed it will be 80 degrees Celsius, on the nozzle 300, and the maximal flow is 15, and the cooling between 30 and 60%, which I find a little bit high. First I print this open-end wrench. Two things I want to check here: if the filament break inside the Teflon tube and we have that bigger bending, and also I'm using texture PI sheet without any glue on it. Set temperature is 80 degrees Celsius on the bed. I'm curious how strong or weak will be the adhesion. It started, so no problem with the brittleness of the filament. Only we will see the bed adhesion, but I'm very curious. Let's see the purge line. It will be fine. It is good that I have this test print because the chamber temperature is set to 0. It will be fine, but now it opens this ventilation door and it's cooling the printing. It's okay, but I will set the chamber temperature to 40 degrees Celsius and just want this to be closed. I will take it out because I have to wait 20 minutes until the bed cools down. So let's try. Oh, it's removable. Okay. There will be a separate video just for fun, testing open-end wrenches from different materials. After this, let's see the final slicer settings I'm using. I already mentioned chamber temperature 40 degrees, bed 80 degrees, nozzle 300, but the first layer I will change to 290, and the flow rate I reduced to 12 from 15 just to have better layer adhesion, and also reduce the part cooling. From this I can already tell that this will be fine printing. Great first layer. Printing is at 77%, the ventilation doors are closed now and it heated up naturally to 46 degrees Celsius inside. No warping, perfectly straight objects. Last few vertically printed objects, and they also look very nice. Really nice print, there is no unpleasant smell like with ABS or ASA. Light grey, dark grey, finished a few seconds ago. Blue, red, and the black one. It will be finished in half hours. We're ready for the testing, and this big amount of the test objects start to be scary. Just another practical application printed in two colors. Open-end wrench with my Tech Fun logo in it. Too small for a nice readable logo, but I think you get the point. And believe it or not, this is a really functional part because one of my family members lost the open-end wrench which was included in the package. This is for locking this tool. And now annealing of these test objects for the temperature test. They will be annealed on 115 degrees Celsius in Sunlo E2 filament dryer, which is a prototype, and by error it can reach this higher temperature. And after 2 hours I let it to cool down together with the dryer. Visually there is no deformation on these test objects. Before annealing the shrinking was approximately 0.18%, and after annealing this is 0.43%. Soon I will show you the table. Just in front of the camera I am measuring two test objects. The red color. So in this line you can see the average value, and here is the calculated shrinking. And just a reminder, shrinking of average ABS is approximately 0.5%. Tensile test with horizontal printed objects. On the left side you can follow the comparison numbers. And as many of you requested, no music this time. Isn't it more boring without music? I will check the statistics, and if more of you will skip this part, music will be back in the next video. Layer adhesion with vertical printed test specimens. Tensile test, very constant and strong values, bigger than carbon fiber version. Now with the layer adhesion, here you can see my ratings for this kind of test object, and in this case the carbon fiber version was stronger compared to the glass fiber version, but this is very good too. And don't forget, layer adhesion is sensitive to settings, just a little bit more part cooling or faster printing and we can experience reduce in the layer adhesion. And don't forget, I didn't even print it on highest recommended print temperature. Shear test horizontal printed objects. Shear test vertically printed test specimens. Now there are few jumps, and for the feeling I could feel that it broke around 50 kilograms, but somehow it stuck inside and then it broke on much higher rate. But I believe that the real value is actually around 50 kilograms. In horizontal position, very constant results and very similar to the carbon fiber version. Now printed in vertical position, I already mentioned that I had that feeling that somehow it broke and then it rotated and stuck in the hole, so that's why we have these huge jumps. But I think around 50 kilograms is more realistic value, and even then it is stronger compared to the carbon fiber version. Torsion test horizontal printed first 3 objects. Loaded 90-degree rotation.
2.3.
And maximum load. Second 3 objects. Again loaded 90-degree rotation.
2.2.
And maximum load.
2.4.
Vertically printed objects. First 3.
1.6.
And now the second 3.
1.5.
Printed in horizontal position, loaded 90-degree rotation, more or less around 1.8 Newton meters, which is bigger value compared to the carbon fiber version. Printed in vertical position, layer adhesion is important, and you can see more or less very similar around 1.5 Newton meters. I'm not sure what happened here with the dark gray. I'm quite sure that this is some kind of error, but I don't have time to repeat it now. Probably during the holidays I will reprint this and repeat the test, and that summary pattern table will be updated later. Crypt has a deformation on a constant load. It's a little bit hard to have everything in one frame. Load is 1.25 kilograms. $13.90. Too many colors to measure all of them in front of the camera, so they are all measured, and good news is that there is no big difference between the colors, and actually the creep test is the first one which I'm starting with because it's the longest, and then in the meantime I'm doing other tests. But let's jump 5 days. Day 5, so far very similar deformation and very low creeping. 14.17, 14.17, 14.18, 14.19, 14.16, and 14.19. And with really no permanent deformation on them. Crypt has a deformation on the constant load, and the colors are very similar. You can see this on this graph. This is the distance between two reference surfaces, and we can see less deformation on the carbon fiber version. Now the creeping is the difference between 2 days, and here we can see that they are very equal. Even the carbon fiber version or glass fiber version, their creeping is very minimal actually, and very similar. Temperature test in the oven, when I want to record the temperature of the first deformation. M10 not as a small load, except for these two, they are M12. I don't have so many M10 nuts here at home. And this doesn't follow any standard. The closest is ISO 75, but for that I should use 4 times bigger loads. Or let's just call this MTF standard. The first minimal deformation on non-annealed test objects I noticed at 97 degrees Celsius, but they stopped with the deformation. This I noticed with all semicrystalline polymers. They became annealed during my slow testing process. For annealed much later at 185 degrees Celsius. And none of objects deformed completely, not even at 230 degrees Celsius when I stopped the experiment. All this I could notice only by analyzing the footage frame by frame, and this is just one example of my method. Now for the touch they are similarly soft on this temperature, which should be normal since the regular test objects may be partly annealed too by now. Of course I don't recommend using this PET-GF filament on these temperatures. If your objects will still be exposed to higher temperatures, you should follow Polymaker's recommendation, 80 degrees Celsius for regular and 133 for annealed objects. 3-point bending test. Distance between supports is 50 mm, first 3 colors, and I'm recording the deformation under these loads after 1, 30 and 60 seconds. These are the second 3 colors, last deformation under 10 kilograms, and visually there is no permanent deformation on any of them. I forget to change the colors here, but basically they are very similar, no big difference. And these are good values, very minimal deformation. Even that additional deformation during that 1 minute under 10 kilograms is very minimal. But compared to the carbon fiber version, we can see more deformation on the glass fiber version. Impact test, but I have a small problem because this machine is a little bit in the way. I have to figure out somehow how to place this 100 kilogram machine over there. But I will record it maybe under some small angle. I did impact test with my DIY testing machine. Side by side 3 objects from the same color. And usually I don't experience so big deviation. Sometimes I notice this phenomenon when some higher friction filament I use in the AMS. I have to speed up this part, so I will show you just one measuring. I did the impact test on this digital impact tester, and I will show you just one break, and then I will show you 6 pictures with the 3 results for each color. I did the impact test on my new digital impact tester. 2 times slowed down motion video. In the right upper corner you can see the results for one color. Again, quite big deviation in the measuring. Going to the Sharpie testing. The first Sharpie test in this video, white color, 2 times slow motion. This was a really huge work, and this is the very last measuring and I want to record it. Blue, 4 times slow motion video, and all measurings are finally done. And the results of the Sharpie testing, but I will show them again on the graph too. This time smaller deviation, but somehow I don't feel too comfortable using higher friction filaments in the AMS. Results from my DIY ISO impact tester, ISO digital, Sharpie digital, summary for all 3 which you can see on this graph, and these are the average values which you can see here. And for the brittle filaments, this is a typical ratio between DIY ISO and digital ISO testing machines. And this is important because in the future I want to stop doing my DIY ISO impact testing only using the digital machine. And overall this filament is quite brittle, almost like some non-reinforced PETG. And the carbon fiber version is slightly tougher compared to the glass fiber version. All results one more time without any additional comment. This is the result for the creep test, tensile test and the layer adhesion, shear test horizontal and vertical, bending, deformation after 30 seconds, bending test, deformation after 1, 30 and 60 seconds under these loads, torsion test horizontal and vertical, temperature test, impact test, ISO DIY, ISO digital, Sharpie digital, summary for all 3, and these are the average values, and the shrinking. Wow, this was so big work that I don't really want to repeat it. In the future, if I will get, I don't know, 5 or 6 colors from the same material, I will do this detailed testing only with the 2 or 3 colors, and with the rest filaments I will do maybe just a layer adhesion and tensile test. Actually, this is what I'm curious about, because I always have this big delay if I get so big work. Back to these filaments. I already mentioned several times that fiber reinforced PET slowly became my favorite technical filament type, and the glass fibers are even a little bit cheaper compared to the carbon fiber version, and they're not much weaker. In some cases they are even stronger compared to the Polymaker's carbon fiber version. And glass fibers, this means we will have more options for the colors, because carbon fibers are black. Additionally, I noticed that all fiber reinforced filaments are more sensitive to moisture, and the glass fibers we can dry faster if we pre-dry it a little bit in a microwave, until they don't have those RF tags inside. And I got several times comments that I shouldn't use the same microwave for the heating the food and drying the filaments. What a nonsense, I never do that. Always I first heat the food and later I dry the filament. I never do this in the same time. So what's your opinion about these filaments? About that layer adhesion, I know that somewhere somebody claims that it has better layer adhesion compared to the carbon fiber version. In my experience it was a little bit different, but this is still very good layer adhesion. And in the future actually I want to test this. First I wanted to do this with the ABS or ASA materials to see different settings. Part cooling, chamber effect and similar, what is this effect to the layer adhesion. And maybe I will include there the PET-GF filament too. If you have some other experience with these filaments, fill us down in the comment section. Thank you for watching this video until the end, and happy printing!